It's been a while since the last update, but a lot has been going on behind the scenes at Sirius Robotics. I've built a much larger robotics lab with plenty of space. The 3D printer is up and running again, and I'm back to making components for Nova. Making a robotic wild dog anthro has turned out to be quite a monumental task, but it's great fun and I always learn new things in the process. You're looking at the current stage of Nova's hand. The hand has 4 accurately proportioned fingers, but as of yet lacks a thumb. The thumb adds some difficulty to the project, as it needs to move side to side as well as up and down as the fingers do. If all goes to plan, I'll have the thumb designed and working by the next update. It took a few months to get the design from paper to what you see here. The first bones I printed were very chunky and lacked any kind of joints. This was to get a feel for the size of the parts I was going to be working with, before committing to making the real parts. The measurements of Nova's hand are based on the measurements of my own hand. When I started designing it, I drew an outline of my hand and took measurements of each finger. I flexed my hand outwards and gripped inwards to measure the range of motion, and compared my findings to those in a medical textbook that I've been using as a reference to check their accuracy. Getting a little more complex, I modified the crude finger bones I originally printed so they could fit together. I used steel bolts as pins for the hinge joints connecting the finger bones, and for the tendons I used steel cables as I had already used these for the eye design. These were strong, but proved far too rigid to bend over the sharp knuckle joints in the hand without permanently deforming. To fix this, I moved to using nylon cables for the tendons. As these were weaker than steel, I doubled the number I was using for each attachment point. This had the added bonus of stabilizing the joints. I now had a finger which could grip and extend while allowing the tendons to move over the joints. However, the steel nuts and bolts I was using didn't like to stay in place. After just a few minutes of testing, the finger would shake itself apart. The vibrations and turning motion when the finger was flexed would cause the nuts to unscrew from the bolts, resulting in parts of the fingers coming loose. I had previously screwed parts directly into the 3D printer plastic, but this quickly degraded as the threads became shorn off with use. After doing some research, I found that I could melt threaded brass inserts into the plastic, then screw bolts into the brass. I used a custom tip on my soldering iron to heat up the brass inserts until they were hot enough to melt the 3D printed PLA, then push them in securely. After replacing the nuts and bolts with brass inserts and countersunk bolts, the hinges were much sturdier and showed no signs of coming apart during regular use. The range of movement in your hands is higher than you might think. Intuitively, you might imagine that each bone of the finger needs to rotate to a maximum of 90 degrees, but after some reading and measuring my own hands, I found that it can be up to 110 degrees. You can try it for yourself now. Lay your hand straight, then move your fingers towards your palm. While the angle of your index finger might be around 90 degrees, your little finger can rotate further, up to around 110 degrees. After some adjustments to the fingers to let them rotate up to 110 degrees, I was ready to make the first hand. I used brass inserts in the hand bones to anchor the fingers together with plates for the back and palm of the hand. This design was still blocky, as each finger was the same size and length. At this point, I was manually moving the tendons by hand. This was a bit of a mess, as I'm not a great puppeteer, and you can see the movements are pretty inconsistent. I used my trusty science cube to test if the hand could grip objects, and I'd say for a first prototype it wasn't that bad. Of course, for a proper grip, I'll need to use material with a greater coefficient of friction, and one that can deform. Right now I'm thinking of using silicone skin to cover the entirety of the hand, and fit it over like a glove. I'm sure this will look a bit horrific at first, but you have to start somewhere. This brings us to where we are today. A more realistic hand with claws and correctly proportioned fingers. I'm still puppeteering the hand, manually for now, but that's going to change soon. I'm going to use the space in the forearm to fit in a lot of powerful servo motors. This has some issues like heat generation and the rotation of the wrist changing the length of tendons required for the same finger position, but I should be able to get around those problems. I'll be using potentiometers in the finger joints to track the real rotation of the fingers and compensate with more or less rotation from the servos as needed. Another problem is finger splay. If you hold your hand in front of you, you can stretch your fingers apart and squeeze them together again. Most robotic hand designs lack this completely. This, of course, saves in complexity, but greatly reduces the range of motion in the hand. It's a little hard to play the piano or type at a keyboard if you can't splay your fingers. I can't add servos inside the hand without significantly weakening it. Therefore, I'll need to design a mechanism to allow for rotation of the fingers in a cone, and allow them to be controlled in both the X and Y axis. I likely use the same mechanism for the fingers as I end up using for the thumb. Now that the new lab is up and running, I can get back to work on some new designs. In the coming weeks, you should see the thumbs added, as well as the forearms and maybe even the wrists. Of course, the hands aren't the only things I'm working on. I've been improving my sculpting skills so I can create Nova's head. You'll see the return of Nova's eyes inside, as well as her jaw and her ears. I'll be trying out 3D printing TPU for the ears to make them soft and springy, like you might find in real wild dogs. I hope you've enjoyed watching these updates as much as I've enjoyed making them. If so, I'll see you in the next one.